Today we're going to learn about basic derivative problems. So, let's say we have to solve for y prime in A, y is equal to 2x to the fifth power, B, this is supposed to say B, y is equal to x cubed minus 3x plus 2, C, y is equal to e to the power of 5x plus 3, and D, y is equal to 5x cubed times 7x squared. So, as you can see, we're going to go over all the types, or most of the types, of derivative problems. We have the power rules, then we have the exponential rule, which is e to the something power, and then we also have the product rule. And this rule here also uses a chain, this problem here also uses a chain rule. So as we can see, we're going to go over most of these ways to solve the derivatives. So let's start with problem A. Problem A has a simple power rule problem. As you can see, we only have 2x to the fifth power. So we multiply the exponent by the coefficient to get 10. So y prime is equal to 10x, and we decrease the exponent by 1. So minus 1 to get 10x to the fourth power. So the answer to problem A is y prime is equal to 10x to the fourth power. So this is just one power rule. Now let's move on to problem B. So y prime would be, again we see that we have to use the power rule. So you bring the 3 down, multiply it by the coefficient of 1, 3x to the second power, 3 minus 1 is 2, minus 3. The reason this 3 is because we have a coefficient, or an exponent of 1, it multiplies by negative 3 to stay negative 3, and then the exponent decreases to 0, and we know that anything to the 0 power is 1 except for 0 to the 0 power. So the answer to problem B is y prime is equal to 3x squared minus 3, because we know that a constant value has a derivative of 0. Now let's move on to problem C. In problem C, we have to use the chain rule. So the chain rule states that if you have one function inside of another function, you take the derivative of the outer function, which in this case would be e to the x, and you multiply it with the derivative of the inner function. So this is the outer, and this is the inner function. So let's get started. Y prime is equal to the derivative of the outer function. So technically the outer function is e to the x, but we have 5x plus 3 inside of x. So what do we have to do? Well, we have to take the derivative like we're doing e to the x. So like when we take the derivative of e to the x, we have to take it like that. But instead of wherever we put x's in that derivative, we have to put in 5x plus 3. So let me once again restate that. We have e to the x, so we'll find the derivative of e to the x, and then wherever there's an x, we'll put in 5x plus 3. Then we will multiply by the derivative of the inner function. So the derivative of e to the x is, as we know, e to the x. As we can see, we have the x here, so now we have to put in the inner function, which is 5x plus 3 multiplied by the derivative of the inner function. The derivative of 5x plus 3, as we know, is 5. Now let's move on to problem D. As we can see in problem D, we have two terms multiplying each other. So what do we use? Here we have to use the product rule. The product rule states that the derivative of this would be the derivative of the first function times the second function plus the derivative of the second function times the first function. So let's do that. We have 5x cubed. The derivative would be 15x squared times, let's move this over a little bit, so we have y prime is equal to 15x squared times 7x squared. So we found the derivative of the first function and multiplied it by the second function, plus 5x cubed, the first function, times the derivative of the second function. 7x squared would become 14x. So the answer to problem D is y prime is equal to 15x squared times 7x squared plus 5x cubed times 14x.